I love that slide. Okay, so this is the first day of algebra. So some of this is kind of introductory stuff. And again, it's when it comes to taking notes. I mean, you guys are all young. We got no reason to think you're like expert at taking notes. But you need to learn to take the notes that help you, right? I'm not doing a notebook check, and I'm not here to tell you you must take this note or not, right? You got to figure out what works for you. Sometimes it's possible to take too many notes, that you're just like so focused on copying, you're not really thinking about what somebody's saying. So it's up to you to kind of figure the right balance. Remember that what I do here not only is being recorded, but I'm saving these slides as a PDF file. They're also on the website. So if you want to have the notes, you just go home and download them, you know. Or if you like took some notes, but they weren't the greatest notes, you can go in and fill in what you missed. So let's go. So algebra, you know, theoretically, this is your first time in algebra, but you probably did do some kind of like pre-algebra stuff, kind of seemed like algebra. Algebra is the study of mathematical symbols and the rules for manipulating these symbols. It is the unifying thread of almost all of mathematics. The word algebra comes from the name of a medieval Arabic author. His name was actually Al-Jabbar, A-L-J-A-B-R. And that's where most of the algebra comes from. Nobody even disputes that that's where, you know, Europe between the end of the Roman Empire and the Renaissance was in the Dark Ages. And so a lot of the good math stuff didn't come out of Europe at that point. It was coming out of Arabia, India, places like that. And so that's where algebra comes from. You know, you don't have to take a note on that. That's not something you're going to be tested on. The symbols that we use in algebra are usually letters that represent unknown quantities. And those unknown quantities we call variables, right? So one of the three important things we're supposed to get out of this whole class is for you to understand the concept of a variable, right? And for example, X and Y are very commonly used as variables, meaning these are letters, they represent a number, but we just don't know what the numbers are when we're looking at them. But even though I don't know what they are, I can add them up. I can write down X plus Y. Now, do I know what that equals? No, I don't, because those are unknown. X and Y are both unknown quantities, so certainly there's some, when I add them together, that's unknown quantity. Right? That kind of thinking when you're trying to, you know, work with things you actually don't have a solid understanding of what they equal, that's called abstract thinking. And algebra is always equated with the beginning of abstract thinking. It's usually considered to be a thing that your brain really isn't even ready for until you're about 14 years old. Right? So how many of you are about 14 years old now? How many of you are 14? It's a lot. I mean, this is the age when really your brain is supposed to be getting there where you can kind of handle this kind of thinking, you know, dealing with variables instead of the actual numbers themselves. Okay, so X plus Y, what I wrote in the last slide, that's called one of three things. You could call it a variable expression, right? Variable because it's got variables in it. Sometimes we call variable expressions algebraic expressions. Means the same thing. And actually, most of the time, we just say expression. Right? Expressions can have numbers, can have letters, can have addition of operations going on in them. You put them all together, that's what we call an expression. These are at the bottom of the screen there. Those are 4 expressions. Right? The first one, what's going on in between the 5 and the n? Do you know already? Connor, what'd you say? You're nodding your head. It's a multiply, right? That is, in words, you would say 5 times n. But actually, there's a couple other ways that we represent multiplication that you need to know, because we'll do them in different ways all the time. You could also write, one second, get back to blue here. 5 parentheses n. That also means 5 times n. There's one more. Does anybody know the third way we write multiplication? Well, except for the x, we're not going to use that. The dot. You know, you could say 5 dot n, and that means 5 times n. Right? That is 5 times n. Okay, the second one, 14, it's a fraction, 14 in the numerator, y in the denominator. What operation is that? That's division, right? So, I mean, that literally means 14 divided by, using a division symbol, y. But usually we're not going to write it like that. It'd probably be 14 over y. So that is 14 divided by y. Okay, the next one, how would you say that one? 6 plus c, right? 6 plus c. And the last one? 8 minus x. My guess is you've done this stuff before. This is probably somewhat of a review. Are you good with that? Okay. So to evaluate an expression, seems like I missed a slide there. That's okay. I guess that's the way I did it. When we say evaluate an expression, it means you've been given a value for the variable, and you're supposed to substitute that value into the variable in the expression and then simplify. So, for example, in this first one, it says evaluate the following expressions if n equals 3. And I'm supposed to take that 3 and put it in the place of n there, right? Which is going to make this 13 times 3. I use the dot. Okay, now simplify. And if you can't simplify, use a calculator. That's why, for this lesson, I have no problem with you using a calculator to do this kind of calculation. What is 13 times 3? 39. Okay, second one. What is 9 divided by 3? 3. Okay, what is 3 minus 1? 2. What is 3 plus 8? 11. Okay, so that's it. You got to know what it means to say evaluate. There's only 2 things we do with expressions: simplify and evaluate. That's all we do with these things. Everybody got caught up on that? Right? Good. So next. So this is the first of what I call you try. This is where you do this now. Based on what I just showed you, try to do the same thing. Question like this on a test, it says evaluate. You need to show your work. There needs to be a step where you show 6 times 2 equals 12. Right? 8 divided by 2 equals 4. 2 plus 4 equals 6. And 11 minus 2 equals 9. So those should have been the 4 answers: 12, 4, 6, and 9. Did anybody have any questions about that? Pretty basic. Okay, won't make any more out of it than we have to. I think that is 6. A little confused here. Okay. Okay, this is a word problem. How many of you love word problems? Most students don't like word problems. Believe me, in every level of math, they say, I don't want to do a word problem. But if you have any idea of being any kind of like science related, engineer, anything, you do word problems. You just do, right? Most of the time, if in the section that you're dealing with, you first, before you get to the word problems, which are always at the end, you've already done a whole bunch of problems where they weren't word problems, they were just specific to that lesson. Then you get to the word problems, and you know what it's going to be about. It's about the same thing that you were doing. It's not like you got to guess what it's about. And a lot of times you can almost just like zoom in on the equation. Don't worry about the words. Get to the equation that looks like what you already solved. But try something. In this problem, and this is being copied from our textbook, which was published in 2007. It said the total cost of seeing a movie at a theater can be represented by the expression A plus R. Again, what are A and R? They're variables, right? Where A is the cost of admission and R is the cost of refreshments. Suppose you paid, and this is before 2007, $7.50 for admission and $7.25 for refreshments. How would you find the total cost? What are they really asking you to do there? They're asking you to evaluate A plus R with the given values of A and R. I mean, in your mind, you're not going to, you're just like going straight to the answer, which is understandable, right? But it's really a question about evaluating, like we just did on the last slide. So I'm going to substitute 750 plus 725. And what does that equal? 1475, right? Now, I think I've got another slide on that. Okay, do you think that those are reasonable values, 750 and 725? What is it? I think the admission's not too far off, is it? What is it? Yeah, that's not too far off. But refreshments are no way 725, right? You can hardly buy a Coke for 725. That's what kills you about going to the movies these days. What would be a more reasonable figure now? Admission $8? Adam? For admission? For everything? Okay. And it depends if you go in the afternoon, right? You get a different price and all this stuff. I would guess like $8 is not a bad. So maybe it'd be better if we said A is $8. And how much do you usually spend on your refreshments? I mean, about $15? Yeah, probably. That would probably be the more realistic to today, right? So that means just to go to the movies, you better have about $23. And if you're going with a date, you better have about $50. Yikes. Okay, now a couple things. This is number 5, page 5, number 3 in your book. Okay, it's not a homework problem, but I want to show you a couple things before I let you do homework, because we're done. This is basically the lesson for today. Evaluate 15x. Evaluate 15x when x equals 4. What are we supposed to do with that 4? Put it in the place of x, right? So this is 15 times 4 equals 60. Okay, now with the class set of books, which is underneath the desk, please take out the Algebra 1, the orange book, and turn to the back of the book to the section that says selected answers. You got to get in the habit of like checking your work. It should be on page 5, number 3. So go selected answers in the back of the book, all the way in the back. I think it is. Yes. Let's see. Is it in the back? Okay. It's in the yellow section, which is all the way in the back. Okay, so now you go to page, where does it say page 5? Page 5, number 3. And you could see the answer is 60. So you check your work, right? And it seems like it's correct. Okay, now go back to page 5. Go back to page 5. And notice it's actually page 6, number 51. Yeah. What's that? Okay. Because that was added. There you go. You're welcome. If you turn to the back of the book, before we do the problem, turn to the back of the book in the same section and look for number 51. Do you see it? 41, 43. You don't see it. That's 6 and 7. A. It actually does have it there. Sometimes, if you notice in the book where 51 is, it's circled in red. Sometimes when it's circled in red, you're not going to find it in that section which says selected answers. You're going to find it in the section right before it which says worked out solutions. So if you get one like that, sometimes I assign those so you can go look at the worked out solution where they give you all the work too, okay? So just understand there's 2 places to check answers in the back of the book. Selected answers for almost all the odd numbers. Sometimes you have to look in worked out solutions for the circled odd numbers problem. Okay. And then let's just read through this problem. You are buying a tank for 3 fish. You have a flame angel that is 3.5 inches long, a yellow sail fin, tang, never heard of that is 5.5 inches long, and a coral beauty that is 3 inches long. Okay. What's the total length of those 3 fishes? What would you do to find the total length? Add them up. Okay, so use your calculator. Tell me, what is 3.5 plus 5.5 plus 3? Okay. 3.5. Remember, you got a calculator to help you with calculations. Plus 3. And that is 12 inches. Okay. The area, you got to buy the tank. So you're trying to say, well, how big of a tank do I need for these 3 fishes? Well, there's a formula for that. The area in square inches of a water surface needed is given by the expression 12F. 12F is an algebraic expression. And what is F? It's a variable, right? It's a variable. And they're telling you F is the sum of the lengths of all the fishes. So we're trying, what do you think we're supposed to do now if we want to find how much water space we need for these fishes? Yeah, I mean, this 12 right here, that is F. That's the sum of the lengths of the fishes. So you're going to put that here and get 12 times 12. Okay, so how much square inches of surface? 144. So if we're going to make this in units, inches squared. So is that a hard word problem? Not that much. If you read it, if you don't just like give up on it before you actually start it, you could actually do something like this. But the main reason I wanted you to see these is just so you understand how to check in the back of the book. So we don't get like 2 months into the class and you're like, I didn't know I could go back there. You can go back there. Right. The homework for today, so our only objective for today was to evaluate expressions, and we did that. And the homework is from page 5, and you can see that there is a mix of odds and evens. So the odd numbers that you can check, you should check. Okay. And we've got like 20, 25 minutes left in class, even with the mix up at the beginning. So you need to be working on this. Okay, that's using your class time well if you want all the classwork done. Any questions? Okay.